On the completion of my own physics degree, I would like to enlighten others on what content you can expect to be involved when studying physics. You will start off with broad courses with titles that cover most of the areas you will spend the next years going into more depth about. These areas include introductory mechanics, waves, thermodynamics, electromagnetism, the special theory of relativity, and the quantum theory of matter. To pass these courses, you will need to understand how to pull information out of a question and plug it into a formula you conveniently spotted on a formula sheet. Practice and understanding helps, but there is a certain distance you can freestyle with educated guesses and a process of elimination. You need enough algebra and trigonometry to be able to rearrange these equations to get any variable you want. The next year, relativity becomes calculating the dynamics of particles traveling near the speed of light and getting your head around space-time transformations in different reference frames. Quantum theory becomes solving the Schrödinger equation. Waves become optical matrices. Mechanics is supposed to be understanding how a gyroscope works, but I still don't think I do. Electromagnetism is the connection that electrons move at relativistic speeds, and people will keep mentioning Fourier series. You will write long lab reports for experiments that almost make sense, and that will either bring you and your classmates together or drive you apart. In New Zealand, a physics degree is 3 years, and in my third year, I was exposed to the world of lattices that make up materials. There are equations to predict gases, and particles with lots of names. There are 2 big pillar courses that were both tough and rewarding: classical mechanics and advanced quantum mechanics. Classical mechanics looks at everyday objects and translates them into the language of Lagrangians and Hamiltonians, where energy and symmetries can reveal solutions to complex problems. It touches on a new description of special relativity with tensors. Quantum mechanics starts to be written in Dirac notation, and you talk more about commutators, observables, and spin. You will usually have the chance to do your own research project for a semester. If you are lucky, this will be working with a supervisor on a real problem in physics and applying some of what you've learned and some of your own ideas to doing real research. If you are unlucky, you will be given some fake problem that students toil over every year and write a mess of code in the process. Just enrolling in a course and existing in the lectures won't get you a physics degree. You actually have to learn the content. By third year, you will be given less and less resources and expected more to derive anything you can't remember. At many times, it will seem like there is too much to be done and that it is impossible to learn enough of it. You certainly need to be able to apply a bit of minimum effort, maximum gain, recognize what needs to be done, and don't toil over details that aren't important. Much of the learning process seemed inefficient, but you need to work out how to work the most efficiently in that environment. I have graduated from my degree feeling like I know very little physics. You are exposed to many different areas, and the problems I were given and had time to work on were only a subset of what could have been done. Going further, you can choose to specialize in one or more areas, but Gone are the days where one could be a true expert on all of physics. I'm happy to answer any questions from people wanting to go down the same path, and good luck with your studies.